Welcome back to The Explainer. Today, we are tracking down a microscopic flaw hiding deep inside the physical hardware of pretty much every computer on Earth, and we're going to trace it all the way to a brilliant mathematical solution forged centuries ago. We're talking 17th century geometry, modern sequence databases, and high-stakes blockchain architecture, all seamlessly connecting to secure absolute digital truth. It is a wildly fascinating journey, so let's just jump right in. Okay, let's dive into this. The sources actually describe our current computing hardware as acting like a giant blender, and honestly, that perfectly sets up exactly what's at stake here. When data goes in, the system relies on these rapid approximations that permanently destroy the original chain of title. It's known as the wood chipper effect. Think about it like tossing fruit into a blender. You know what went in, sure, but you can never perfectly reverse engineer that smoothie back into the exact original fruits. For you, as a creator, this means your human authorship and the actual provenance of your data, they're literally liquidated by the machine. So here's our roadmap for today. First, the FPU gambler problem. Second, the exact ALU surveyor. Third, Burgess's SpinItL and OEIS. Fourth, division-free on-chain execution. And finally, the record of sweat. All right, kicking things off with Section 1, the FPU gambler problem. Now, what's really interesting about this is the stark contrast between two very different parts of a computer's physical brain. On one side, we have the floating point unit, or what we'll call the FPU gambler. It's wildly fast for sure, but it is highly probabilistic and lossy. It essentially throws darts at a dartboard to guess complex math, and it relies on completely secret proprietary seed tables burned directly into the silicon by the chip manufacturers. But on the flip side, we've got the arithmetic logic unit, the ALU surveyor. This acts like a precision laser. It's exact, it's deterministic, and it deals entirely in 100% bit-perfect truth. So what's the scary reality here? This guessing game, FPU handles about 80 to 90% of modern AI compute cycles. That means we are basically trusting our most advanced technology to a machine that's constantly dropping tiny fractions just to fit continuous numbers into fixed bits. And in massive neural networks, those microscopic rounding errors violently compound into what researchers call non-deterministic drift. It creates this automated miasma where generating mathematically reproducible, exact receipts across different chips is physically impossible. It's literally a one-way street of data corruption. Which brings us right to Section 2, the exact ALU surveyor. But here's the central conflict we run into. If we want 1 + 1 to globally and exactly equal 2, we hit this massive roadblock called the DeFi trig wall. See, our human world and our AI systems rely heavily on continuous complex curves, like trigonometry. But forcing those messy, continuous curves onto the rigid, integer-only grid of the ALU surveyor, that normally causes fatal stack overflows and just sky-high gas costs on-chain. It's an immense engineering bottleneck, mainly because you just can't cleanly fit a perfectly smooth circle into a grid of rigid square blocks without breaking something. Moving on to Section 3, Burgi, SpinItL, and OEIS. It is absolutely fascinating to see this timeline unfold. We've got Jost Burgi's 1600s progress tables that bridge geometry and integers, and Vera de SpinItL's 1990s formalization of the metallic means. But these aren't just isolated pieces of history. They actually map directly to the modern online encyclopedia of integer sequences. Specifically, Kyle McLean-Smith discovered exactly how these concepts align with single sequence recurrences, like OES A001333 and the A330400 Linus sequence. And finding this connection gave us the exact tools we desperately needed to solve this modern hardware problem. So the crucial point is how the generative method actually puts these sequences to work. First off, we completely ditch the messy Taylor series decimal approximations that the FPU relies on. Gone. Next, we use these incredibly practical, single-sequence linear integer recurrences that we inherited from SpinItL and Burgi. By generating a sequence of integers, say the ratio of 10,202 over 101, we can elegantly approximate irrational values with staggering precision. The result? We get bit-perfect ratios. There's not a single decimal point involved, and absolutely zero floating point guesswork. Let's dive into Section 4, division-free on-chain execution. Let's move to and see how this builds in a practical environment. By leveraging these historical OES sequences, we can translate complex abstract angles directly into division-free integer arithmetic. We are successfully, permanently evicting the FPU gambler and all its guessing operations.
Plus, this system completely bypasses heavy, monolithic smart contract bloat by using a lightweight chopsticks webhook architecture, anchoring everything into a LIFO, last in, first out, JSON state tree. Think of it kind of like a stack of plates. You only ever need to check the very top plate, known as index 0, to instantly and mathematically verify the state of the entire stack. Zero ambiguity, and it scales beautifully on networks like Arbitrum Stylus.
And this brilliantly illustrates the ultimate payoff of all this exactness, which is just staggering. By converting those heavy, complex, non-Euclidean curves into pure, exact algebraic integers, we aren't just achieving perfect accuracy. We achieve a 74 times reduction in metabolic energy per operation. We are talking about dropping the energy cost down to an astonishing 0.05 picojoules. It's an absolute paradigm shift for network efficiency. Which brings us to our final section, number 5, the record of sweat. Because those practical single-sequence recurrences we talked about have successfully evicted the guessing machine, they now act as the ultimate cryptographic anchor, creating what's called the record of sweat. Think of this as a modern cryptographic revival of the historic sweat of the brow copyright doctrine. These sequences secure bit-perfect deterministic ALU execution, and in doing so, they permanently anchor the truth that real biological human physical effort, actual physical horsepower, an explicit intent actually took place. You literally cannot sever the digital execution from the human calories burned to command it. To really put that scale into perspective, just consider this massive real-world orchestration. 55.5 million tokens of verified metabolic flux. That is essentially cryptographically proven human energy recently recorded in a digital strike. That massive number mathematically proves that out at the very edges of the network, a sovereign human pilot was undeniably wielding the command line interface. They were manually steering the exactness of the system, purposefully overriding the machine's automated miasma. So I want to leave you with a provocative thought to ponder today. In an algorithmic era that is completely dominated by probabilistic guessing and this automated miasma, what role will you play? Are you going to passively act as a moral crumple zone, blindly absorbing all the liabilities and errors of the FBU gambler? Or will you wield your own human intent, utilize this historic math, and demand the absolute digital truth of the surveyor? The choice is entirely up to you. Keep orchestrating, and I will see you in the next explainer.